DEBACOAT, development of high-performance barrels with innovative gradient coatings, is an FP7 research project aimed at the development of bimetallic barrels with innovative internal coatings for polymer extrusion. Among private companies, Bernex is the coordinating partner, located in Czech Republic, specialized in the production of bimetallic barrels for plastic injection and extrusion machines. Aeroviti in Italy deals with finishing of screws and barrels for plastification units. GNC Laser is a Spanish company specialized in laser systems, mainly related to hardening, welding and cladding. Finally, NT Neue Technologie System Lösungen is a German enterprise producing metallic alloy powders. The research centers involved in the project are the Fraunhofer Institute for Material and Beam Technology from Dresden in Germany, IK4 Tecniche from Spain, and Politecnico di Milano, Department of Mechanical Engineering in Italy. The research team has a good combination of expertise in laser systems, manufacturing technologies and material science. Today, a very large amount of plastic raw material is processed by screw extrusion and by screw injection molding techniques. Basically, the polymer feedstock enters through a hopper in the feed throat and comes into contact with a rotating screw. The rotating screw forces and drives the plastic through the heated barrel, where it is mixed and progressively melts. Extra heat is generated by the intense pressure and friction taking place inside the barrel. After processing, the material is delivered to a die that gives the final product its shape. Either single or twin screws, cylindrical or conical barrels may exist, depending on production and material requirements. But the degree of equipment wear, especially of barrels, for these techniques represents one of the most concerning issues. It determines the economical feasibility of processing. For this reason, in heavy applications, a hard coating is formed on the inner surface of barrels. Different sections along barrel length are subjected to specific loads in terms of different friction, temperature, chemical attack, and mechanical stress due to the different processing conditions experienced. Barrels are internally coated to obtain bimetallic barrels by spin casting or by laser cladding. Research actions have been undertaken to develop new alloys for the spin cast coatings. Alloys have been first studied by laboratory experiments to simulate the behavior of the material and the effect of dilution and casting during processing of bimetallic barrels. Castings of small volume samples have been performed to analyze material structure and properties such as hardness, wear behavior, and corrosion resistance. In particular, an innovative technique for the production of internally coated barrels with a layer having variable composition was developed. These gradient composition bimetallic barrels are successfully made by first laying different sets of powder feedstock having specific compositions in the inner side of raw barrels, separated by special steel rings acting as dividers during melting. After spinning, optimal composition in each of the barrel sections is achieved. Optimization of laser cladding deposition parameters inside the barrels has been carried out, and processing monitoring devices have been developed to control this very complex process while working inside a very hot and narrow barrel. Moreover, a special laser head has been designed, realized and successfully tested for very thin barrels. The Mini ID laser head is able to continuously perform cladding inside barrels with inner diameters down to 58 mm and total length up to 3 meters. A special deposition strategy was needed in order to cover the irregular and non-symmetric inner surface of twin barrels having double cavity for the two screws. By optimized processing parameters and specific laser tracks during cladding, such complex geometries could be successfully cladded even with very hard alloys reinforced with tungsten carbides. In a final stage of the DEBACOAT project, working prototypes have been produced in the industrial facilities of partners involved, and products have been tested in real industrial production to assess service performance, showing improved properties.